And good morning, everyone. For this one, we're going to look at determining the domain and range for exponential functions. And we're going to do it by looking at the graph of the equation. So let's review domain and range. So your domain for a function is going to be all your x values. All your x values. And your range for a function is going to be all your y values. So if you're looking at a graph, for the x values, you're going to be looking at all the possible numbers that could go in for variable x, so your x-axis. And for your range, you're going to be looking at all the numbers that could go in for the y values. So you're going to be looking at your y-axis. And if, let's say, we had a function, let's say we had something that looked like this. And we're trying to describe all the possible x values. So let's work on the domain first. If we were looking for the domain, so what are all the different x values? So it looks like it could be any x value here, all these possible x values. Since the graph keeps going indefinitely, then all these x values would be possible x values for this particular function. And technically the graph keeps going up and up and up and up. And as it's going up, it's still drifting to the right, so all these x values are going to be possible x values, and it's going to keep on going indefinitely. So for the domain, for your x values, so we would say the domain would be all real numbers. And the range, if we look at the y values, notice the y values are going to be limited. You're not going to get any y values that are below the x-axis for this particular type of function. They all stay above the x-axis. So all your y values are going to be 0, so starting at 0 and greater. So all your y values are going to be greater than 0. So for the range, we'll go ahead and say that y needs to be some number bigger than 0. So y is going to be greater than 0. And it's not going to be equal to 0 because it's never actually going to touch the x-axis. So the graph will never actually touch the x-axis, so we'll get as close to the x-axis as it can. So the y values are going to stay greater than 0. And let's go ahead and do a few problems that we will see on IXL.com, section X.3, X.3 from the Algebra. So question 1 says, what is the domain? So what are all the possible x values? Pretty much the answer for any exponential function is that you can put in any x value that you want for an exponential function. So any x number, you can keep going to the right for all your x values. If you keep going to the right, then your graph just keeps getting taller. You can put in any x value to the left, and it keeps going forever. So the domain for an exponential function is pretty much going to be all real numbers. So for this one, your domain is going to be all real numbers. And looking at the next question, this one they want to know the range, so all the possible y values. So looking at this graph, it looks like it's approaching the x-axis. It's never going to touch the x-axis. So all your y values are going to stay greater than 0. So y is going to be greater than 0. and we need to find that in the answer. So this right here, they just call this set notation. So the brackets here stand for a solution set. So they're saying a solution set for a variable y such that y is greater than 0. So this one right here, y is greater than 0, that's what we're looking for. So we're going to go ahead and answer the range is this one, y is greater than 0. And next question looks pretty similar. It wants the range. The graph is approaching the x-axis, so everything is going to stay above the x-axis. So we're going to say y is greater than 0. So we want to find that, which is right here. Y is greater than 0. And this one they want both. They want the domain and they want the range. So the domain, we know that's going to be all reals. So we need to find the ones where the domain says all reals. So domain all real numbers, that's this option. Domain all real numbers could be this one. And then we just need to look at the range. So if we look at the y values, this dotted line, it's approaching this dotted line at -7. So your y values are going to be above -7. It's never actually going to reach -7, so we want to find something where the range says that the y values are greater than -7. And we don't want them to be equal to -7 because it's never actually going to touch that -7 line. So we're going to want this one, domain all real numbers, range y is greater than -7. And the next one. So again, they want the domain and the range. So domain, we know that's going to be all real numbers, so we know it's going to be this one, or it could be this one. And let's see which one makes the most sense. This horizontal line is at -5. So this is at -5. So your graph is going to approach a y value of -5, but never quite get there. But in this case, your y values are going to be less than -5. So y is less than -5. So which one has y is less than -5? And it looks like it's going to be this one. And I believe, yep, that is the last example. So I will let you go ahead and get to work on IXL module X.3. Have a good day.